thank you all for joining us on the Person to Person Network. Welcome to Profiles in STEM. Our career series will feature an amazing STEM professional who is shaping lives and building the future. I'm your host, Katie Culbert, and if you haven't already done so, please leave a like and subscribe to our network. Joining me today, we have a very special woman in STEM, Dr. Lavina Backman. Dr. Backman is a materials engineer in the Spacecraft Engineering Division at the United States Naval Research Laboratory in Washington, D.C. Dr. Backman, welcome to our program.
Thank you for having me.
It's a pleasure to have you, Dr. Backman. So, did you always know you wanted to be a scientist? And can you tell us about a specific moment that first inspired you to pursue a career in STEM, and even more specifically in materials engineering?
So I didn't always know that I wanted to be in STEM. I was originally going to go down a path for studying hotel management and going into business management. Um, but after I spoke to a mentor in high school and really thinking about what I wanted versus what I thought I should be doing, I realized that I had a lot of interest in science and engineering that was really spurred. Funnily enough, I grew up in the Philippines, so it was spurred by science fiction of all things. And thinking about it, I realized that, I have some talents in literature or the liberal arts. I had some talents in business management, but if I wanted to go to school for something, I wanted to to school for something that I wasn't already, inherently good at. I wanted to learn something new and challenge myself. And so, based on that, I decided to do mechanical engineering. Um, and the path, sorry, the path down to do material science actually happened in the course of my job. While I was working, I got really interested in material science. A lot of the problems I was dealing with had to do with material strength and corrosion resistance, and that made me realize how interested I was in material science.
Thank you for that. That's a really amazing story. I think it's cool that you wanted to challenge yourself instead of just sticking to what's uncomfortable. You went through the uncomfortable and now you're here in this career. So, without getting too technical, can you tell me more about what you do and share some insight into the duties that you serve at the U.S. Naval Research Laboratory?
Yeah, without going into too much detail, my expertise is in materials that can get really hot. So these materials can have melting temperatures of 4,000 degrees, almost 4,000 degrees Celsius. So that's really hot. For reference, the surface of the sun is about 5,300 Celsius. So we're getting really close to those kinds of temperatures. But at those temperatures, when you expose these materials to air, the oxygen in the air reacts with these materials very quickly. So my background and expertise and a lot of my job is to understand how to develop new materials that are going to are much better behaved in air. You don't want if you have a really fast rocket coming in from the atmosphere, you don't want it to disintegrate because it was oxidizing or reacting with oxygen. And so, when a big part of my job is taking the requirements that are given to me and looking at the materials that are available, designing new materials if I can, and then testing their behavior.
Thank you so much for sharing that insight with us and really breaking it down so we can understand more of what you're talking about. So, Dr. Beckman, over the course of your career, you've had the choice to either pursue civilian and academic research. And so, what inspired you to pursue a career in naval research?
I found that I was really motivated um, by a mission. So what was important to me, I'm a naturalized citizen and I take my role as a citizen of this country very seriously. And so what's really important to me is how to further our collective understanding of the next greatest technology, how to push the boundaries of technology further, how to use that in the service of something that has a lot of meaning to me, and that's this nation's defense, keeping this country safe, but also keeping us able to to be at the forefront, just like we were at during the space program, be at the forefront of technology.
Thank you for sharing what has inspired you throughout your career. And I can really see how this motivation has pushed you really far in your career and that you're extremely passionate about it. So let's switch gears really quickly and talk more specifically about what you do. Can you describe an example of your past or current research investigations right now and its potential implications?
So I can't go into a lot of detail, but what I can say is that, that just like I mentioned earlier, we are trying to really push the boundaries of how hot materials can go and how hot can they go in air, and what does this mean for our aircraft, and even for pushing boundaries in space. I work in the spacecraft engineering division, and so matters related to materials for space are important. So, how cold can things get? How hot can things get? How do we harvest energy from waste heat? All of these questions are things that are within my purview to try and answer eventually. But right now, my focus is on high temperature materials. How hot can it go? And the implication is, well, a good example is, you thought of, I don't know if you have heard about the Columbia accident, the Space Shuttle Columbia accident. So the Space Shuttle Columbia accident failed because of damage to its thermal protection system. But before that, decades of excellent um, we've had decades of excellent success, if you will, in space exploration and reusable spacecraft, and being able to come into the Earth's atmosphere experiencing temperatures on the order of 2000 degrees Celsius, which is, trust me, very hot, and getting our astronauts safely to the ground. So, the more we understand how materials behave at those temperatures, and the more we push the boundary of what current materials can do, the implications could be making um, missions to Mars more routine. It could be being able to fly from India to New York in 5 hours instead of 14 or 20. So, yeah.
Thank you so much for sharing. It sounds like really cool and exciting work, and it's definitely extremely important. So, with so many potential directions in research, how do you determine exactly which projects to pursue?
So there's two ways that I look at projects, or I look at the motivation for pursuing a specific project. One is what is the Navy's mission? I think that's really important. For the DoD as a whole, most DoD labs are mission driven. And so, how do we help keep the warfighter safe? How do we keep our soldiers safe? How do we make sure that they have a technological edge in order to keep them safe and keep us safe in return? And so, there is a mission alignment piece to whatever I consider pursuing. The second piece is, past work or past research in this material in this field um, raises new questions, and these questions have really important implications, as I discussed, in your previous question, in terms of maybe this is the path we take to really get to this is the path we take to get to high temperature materials that can be easily assimilated into new spacecraft or new rocket engines. So there's twofold to that. Are we answering an important question so that we can further further push that boundary, and are we also aligned with the Navy's mission?
Thank you for sharing that insight. It must be extremely fulfilling for you to know like your research has a direct impact and is able to protect the brave men and women who serve our country and even us civilians here at home. So we've explored many areas today, and I wanted to thank you for letting us have a glimpse into your very interesting and exciting life. As a parting thought, is there something you would like to share with our audience as they continue to explore STEM and careers in STEM?
Yeah. One thing that I think is really important as you look to explore STEM as a career path is the need for hands-on lab work. Even if you think that you're going to be a computational work researcher where you just do simulations or you do programming or you do data analysis, it is so important to get your hands dirty. Go into the lab, volunteer for odds and ends, be a magpie with your skills. Try to get as many skills as you can in terms of hands on capabilities. And that will only enrich any kind of work that you do. Um, Before I went to grad school, for example, I didn't really have a lot of experience in a research lab. And I learned such a wealth of knowledge that not only helped me in my career, but also helped me in my day-to-day life. Fixing things no longer felt impossible because I've taken a 1500 degrees Celsius furnace apart and put it back together. And so when you do these things, it makes the science more immediate. It makes it more, I want to say, makes it more tangible, and it really spurs the way you think about science in a really good way. And finally, I would say that don't be afraid to ask for informational interviews. And I don't mean like an interview like we're having, but I mean talk to as many scientists as you can talk to as many engineers as you can talk to, understand their day-to-day life, how they got there. You'd be surprised at what you find. My career was not straightforward. I had to take a lot of twists and turns to get to where I am. Um, and I think that it's really important to understand that when you hit a roadblock in pursuing a STEM career, or if you hit a roadblock, it usually ends up being a good thing. You learn from that and you end up um, yeah, you end up understanding more about what drives you, what is interesting to you, and that passion can only be translated to better science.
Thank you so much for sharing that amazing advice with our audience, and I hope that they will take it to heart, especially your advice about trying new things and not being afraid to learn new things and get outside of your comfort zone. So, with that, I would like to thank my very special guest, Dr. Lavania Backman. Dr. Backman, it was truly an honor to be speaking with you today. Thank you for spending time with us. And to our viewers, please join us again for another exciting remarkable STEM professional, and don't forget to leave a like and subscribe to our network. Thank you so much for listening. Katie Culbert signing off.